Right now, as you lie in the dark, billions of invisible particles of dark matter are passing through your body and brain without a sound. They do not stop. They do not slow. They move through your skin, your bones, your thoughts, like light through glass, the phantom scaffolding of the universe, mirroring the vast, unseen architecture of your own subconscious. And tonight, you and I are going to follow them. Over the next 2 hours, we will walk together through 100 calm, astonishing truths about the invisible universe and the invisible mind, a journey into the great unknown, told one quiet fact at a time. Because here is what science has slowly begun to understand. Roughly 85% of all the matter in the cosmos is missing. We cannot see it, we cannot touch it, and yet without it, no galaxy could hold its shape, no star could find its place. The universe is built on absence, and so, it turns out, are you. The deepest structures of human consciousness, the neural dark energy that hums beneath your thoughts, the gravitational ghosts of memory that shape your dreams remain as mysterious to neuroscience as dark matter remains to physics. The missing mass of the cosmos and the missing link in our understanding of the mind may be reflections of the same beautiful riddle. So let this be a dissolution of the self, slow and willing. Each fact you hear tonight is a gravity well, pulling you gently deeper into a state of weightless relaxation. We will move through cosmic webs that stretch across billions of light years. We will drift past galaxy clusters held together by forces no instrument has ever directly seen. And as the universe reveals its hidden face, your mind will find its ultimate stillness. You do not need to understand the math to feel the peace. You do not need to remember every word. Just breathe. Let the invisible universe carry you into sleep. In the early 1970s, an astronomer named Vera Rubin sat in a quiet observatory and watched galaxies spin. She was not looking for anything extraordinary. She was simply measuring the speed at which stars orbited the centers of spiral galaxies, expecting the outer stars to move slowly, the way distant planets in our own solar system drift lazily around the sun. But the numbers did not cooperate. The stars at the edges of these galaxies were moving just as fast as the stars near the center, sometimes faster, as though something enormous and invisible was pulling them along. The math was clear. The gravity of visible matter alone could not account for what she was seeing. Something else was there, something vast and hidden, exerting a force that no telescope could photograph and no instrument could touch. Vera Rubin had found the first compelling evidence of dark matter, and the universe would never look the same again. What Rubin had uncovered was not a small discrepancy or a minor footnote in astrophysics. It was a revelation that shook the foundations of how we understand reality. The missing mass, she inferred, was not a thin veil draped lightly over the cosmos. It was the cosmos. Later measurements would confirm that roughly 85% of all matter in the universe is dark matter, invisible to every wavelength of light, undetectable by any direct means we possess. The stars, the planets, the glowing nebulae, the comets, even the atoms in your body, all of it accounts for only about 15% of the material universe. The rest is a vast, silent ocean of something we have never seen, never held, and still cannot fully explain. You are, in the most literal sense, surrounded by mystery. And tonight, As your body settles and your breathing slows, that mystery is all around you, passing through you, holding the galaxies in place while you rest. Dark matter does not emit light. It does not absorb light. It does not reflect light. It is, by every optical definition, perfectly invisible, and yet it is not absent. It is, in fact, the most abundant form of matter in existence. Imagine standing in a vast cathedral, a space of extraordinary architecture and beauty, and being told that the walls, the ceiling, the floor, the pillars, everything you can see accounts for only a fraction of the building. The rest, the true structure, the thing that holds it all upright, is something you cannot perceive with any of your senses. That is the universe you live in. The visible cosmos, stunning as it is a thin, luminous skin stretched over a skeleton made of darkness. And as you lie still tonight, you are resting inside that invisible architecture, cradled by forces that have been quietly at work since the beginning of time. There is a deep and beautiful parallel between the hidden scaffolding of the cosmos and the hidden scaffolding of the human mind. Neuroscience has shown us that the vast majority of what the brain does happens below the threshold of conscious awareness. Your heart beats, your lungs expand, your memories consolidate, your emotions form and dissolve, all without your deliberate involvement. The conscious mind, the part of you that narrates your life and believes it is in control, is like the visible matter in the universe, bright, noticeable, and strikingly small compared to the whole. Beneath it lies an immense subconscious architecture, a dark network of processes and impulses that shapes your thoughts, your dreams, your sense of self. You are, in a very real sense, a walking cosmos, a being whose deepest structures are hidden from your own awareness, just as dark matter is hidden from the light. To understand dark matter, you must first understand gravity, the gentlest and most persistent force in the universe. Gravity does not shout, it does not flash or explode. It simply pulls, steadily and without rest, bending the fabric of space and time around anything that has mass. It is the reason the moon orbits the Earth orbits the sun, and the sun orbits the center of the Milky Way. But here is the remarkable thing. The gravity we can account for from visible matter is not nearly strong enough to hold galaxies together. Without dark matter, spiral galaxies like our own would fly apart, their outer arms scattering into the void like sparks from a spinning wheel. Dark matter provides the extra gravitational pull that keeps everything bound, a silent glue that holds the cosmic architecture in place. And you can think of this tonight as a metaphor for the quiet forces in your own life, the unseen bonds of habit, memory, and love that hold your inner world together even when you are not paying attention. In the 1930s, decades before Vera Rubin's observations, a Swiss astronomer named Fritz Zwicky was studying a massive cluster of galaxies known as the Coma Cluster. He measured the speeds at which the individual galaxies within the cluster were moving and found something deeply troubling. They were moving far too fast. Based on the visible mass of the cluster, the galaxies should have long ago escaped each other's gravitational pull and drifted apart into the emptiness of intergalactic space. But they had not. Something unseen was holding them together, something with enormous gravitational influence, but no light, no heat, no electromagnetic signature of any kind. Zwicky called this missing component Dunkel materia dark matter, and though his peers largely dismissed the idea at the time, he had planted a seed that would grow into one of the most profound questions in the history of science. The story of dark matter is, in many ways, a story about the limits of perception. We are creatures of light. Our eyes evolved to detect a narrow band of the electromagnetic spectrum, and our entire civilization is built upon what we can see, measure, and photograph. But the universe is under no obligation to be visible. Dark matter reminds us that the most important things in existence may be the things we cannot directly observe. This is true in physics, and it is true in the landscape of the mind. The most powerful forces shaping your thoughts tonight, the deep currents of memory, the gravitational pull of old emotions, the silent hum of your nervous system preparing you for sleep, are invisible to your waking awareness. You do not see them, and yet they are working. Let that thought settle over you like a blanket. The invisible is not the absent. It is simply the quiet. If you could somehow remove all the dark matter from the universe in an instant, the consequences would be catastrophic and immediate. Galaxies would lose the gravitational scaffolding that holds their stars in orbit. Spiral arms would unwind and dissolve. Galaxy clusters would fly apart like shattered glass. The cosmic web, the largest structure in the known universe, would collapse. Stars would still burn, but they would drift alone, untethered, slowly cooling in an expanding void with no structure, no pattern, no connection. Dark matter is not a curiosity or an abstract puzzle. It is the reason the universe has shape. It is the reason structure exists at all. And as you breathe slowly tonight, consider that your own mind has its own form of dark matter, the unconscious processes, the background hum of neural activity that gives shape to your thoughts, your personality, your dreams. Without it, consciousness itself would have no structure to cling to. One of the most stunning discoveries of modern cosmology is the cosmic web, a vast network of dark matter filaments that stretches across the observable universe like a three-dimensional tapestry. These filaments are immense, spanning hundreds of millions of light years, and at their intersections sit the galaxy clusters, the largest gravitationally bound structures in existence. Between the filaments lie enormous voids, regions of nearly empty space that can stretch for hundreds of millions of light years. The universe is not a random scattering of galaxies. It is an intricate, web-like structure, and dark matter is the thread from which that web is woven. When scientists first mapped this cosmic web using computer simulations, they were struck by something extraordinary. It looks remarkably like the neural network of the human brain. The filaments connecting galaxies resemble the axons connecting neurons. The structure of the largest thing we know mirrors the structure of the most complex thing we know. The resemblance between the cosmic web and the human brain is not merely poetic. In 2019, a team of researchers from the University of Bologna published a study comparing the two systems in detail. They found that the number of filaments in the cosmic web is comparable to the number of neural connections in the brain's cortex. The distribution patterns of matter along these filaments follow similar mathematical rules as the distribution of signal strength along neural pathways. Both systems are roughly 70 to 80% empty space, with their functional elements concentrated along thin, branching threads. The researchers did not claim that the universe is conscious or that the brain is a miniature cosmos, but they demonstrated something quietly extraordinary, that the principles of self-organization, the mathematical laws that govern how complex networks form and evolve, appear to be universal. The same patterns emerge whether you are building a universe or building a mind. Let that thought carry you as you sink deeper into rest. Gravitational lensing is one of the most beautiful and eerie phenomena in all of physics. When light from a distant galaxy passes near a massive object, a galaxy cluster, for instance, the gravity of that object bends the light, curving its path the way a glass lens bends a beam of sunlight. The result is that we see the distant galaxy distorted, stretched into arcs or rings, sometimes multiplied into several ghostly copies of itself. Dark matter, though invisible, has mass, and mass bends light. So when astronomers observe gravitational lensing in regions where there is not enough visible matter to account for the bending, they know that dark matter is there, shaping the path of photons that have traveled billions of years to reach our telescopes. It is as though the universe is wearing an invisible mask, and gravitational lensing is the faint outline of that mask, pressed into the light of distant stars. There is a quiet metaphor here for the way your own mind works. Your subconscious does not announce itself. It does not flash or glow, but it bends your perception of reality in ways you rarely notice. The memories you carry, the fears you have absorbed, the beliefs you formed in childhood, these are the invisible lenses through which you see the world. They distort, they magnify, they sometimes create ghostly copies of experiences that are not really there. Just as dark matter bends the light of distant galaxies without touching it, your subconscious bends the light of your conscious experience without your awareness. Tonight, as the thinking mind grows quiet, those lenses soften, the distortions relax, and for a little while you can see more clearly, not because the lenses have disappeared, but because you have stopped trying to look through them. Sleep is the mind's way of setting down its invisible glass. In 2006, astronomers pointed the Chandra X-ray Observatory and the Hubble Space Telescope at a distant object known as the Bullet Cluster, and what they found became one of the most important pieces of evidence for the existence of dark matter. The Bullet Cluster is the result of a colossal collision between two galaxy clusters, an event of almost unimaginable violence that occurred over the course of millions of years. When the two clusters collided, their hot gas, which makes up most of their visible matter, slammed together and slowed down, like two clouds of steam colliding in midair. But the dark matter in each cluster, because it does not interact with normal matter or with itself in any electromagnetic way, passed right through the collision without stopping. It kept moving, separating cleanly from the visible matter. The resulting image showed the hot gas pooled in the center and the dark matter, detected through gravitational lensing, displaced to either side. It was direct, visual proof that dark matter exists as a substance separate from the matter we can see. The Bullet Cluster tells us something profound about the nature of dark matter. It is not simply an effect of gravity behaving strangely. It is not a modification of the laws of physics. It is a substance, a real physical thing with mass and gravitational influence that occupies space and moves through the universe on its own terms. It just happens to be invisible and nearly impossible to detect directly. There is something deeply humbling about this. We have built particle accelerators that can recreate conditions fractions of a second after the Big Bang. We have sent probes to the edge of the solar system. We have decoded the human genome. And yet 85% of the matter in the universe remains a ghost to us, present and powerful, but utterly unseen. Let that humility wash over you tonight. You do not need to understand everything. You do not need to see everything. Some of the most important things in existence are content to remain in the dark. The leading candidates for what dark matter actually is are particles known as WIMPs, weakly interacting massive particles. The name tells you almost everything you need to know. They have mass, which means they exert gravitational force. But they interact with normal matter only through the weak nuclear force, which is so feeble at the scales we experience that these particles pass through solid objects as though they were not there. Right now, as you lie still and listen to this, billions of WIMPs may be streaming through your body every single second. They pass through your skin, your bones, your organs, your brain, without disturbing a single atom. You do not feel them. You cannot see them. And yet they are there, an invisible river flowing through you and through the earth beneath you and through the stars above you, connecting everything in a web of ghostly mass. You are, in this very moment, being touched by the universe's deepest secret, and you feel nothing at all. Deep beneath the mountains of Italy, in a laboratory called Gran Sasso, and deep beneath the Black Hills of South Dakota, in a facility called the Sanford Underground Research Facility, scientists have built detectors of extraordinary sensitivity, hoping to catch a single WIMP in the act of colliding with an atom of ordinary matter. These detectors are buried underground to shield them from cosmic rays and other noise that would drown out the faint signal of a dark matter particle. They sit in silence, in the cold and the dark, waiting. Some have been waiting for years. So far, no confirmed direct detection of a WIMP has been made. And yet, the search continues, because the evidence from galaxies, from clusters, from the cosmic microwave background, from the large-scale structure of the universe, all points to the same conclusion. Dark matter is real. It is everywhere, and it is waiting to be found. There is a strange beauty in this patience, a willingness to sit in the dark and trust that the invisible will eventually reveal itself. Your brain, too, is a detector of the invisible. Every night, as you fall asleep, your brain shifts from the rapid, focused processing of waking life to a slower, deeper mode of operation. The thalamus, a relay station deep in the center of the brain, gradually closes its gates, reducing the flow of sensory information to the cortex. The outside world fades. Sounds grow distant. Light disappears behind your eyelids. And in this darkness, your brain begins to detect signals from within the faint flickers of memory, the gravitational pull of unresolved emotions, the quiet hum of the default mode network, which activates when you stop paying attention to the outside world and turn inward. Sleep is not the absence of awareness. It is a redirection of awareness, a turning of the brain's telescope from the external universe to the internal one. And in that internal universe, there is just as much dark matter waiting to be explored. The cosmic microwave background radiation is the oldest light in the universe, a faint glow that pervades all of space, left over from a time roughly 380,000 years after the Big Bang, when the universe had cooled enough for atoms to form and light to travel freely. When scientists mapped this ancient light with exquisite precision using satellites like COBE, WMAP, and Planck, they found tiny fluctuations in its temperature, variations of less than 1 part in 100,000. These fluctuations are the fingerprints of dark matter. In the early universe, dark matter clumped together slightly faster than ordinary matter, creating gravitational wells into which normal matter would eventually fall, forming the first stars, the first galaxies, the first structures of any kind. Without dark matter, the cosmic microwave background would be perfectly smooth, and the universe would be a featureless fog of hydrogen and helium, with no stars, no planets, and no one to wonder about any of it. Consider what this means. The very existence of structure in the universe, every galaxy, every solar system, every planet capable of supporting life is a consequence of dark matter's quiet gravitational influence in the first moments after creation. Dark matter did not build these things directly. It built the scaffolding upon which everything else was constructed. It created the dimples in the fabric of space-time, where ordinary matter could gather, condense, ignite, and eventually, over billions of years, become aware of itself. You are, in a very real sense, a product of dark matter's patience. The atoms in your body were forged in stars that formed in galaxies that coalesced in dark matter halos. You are starlight shaped by invisible hands. And tonight, those same invisible hands are still at work, holding the galaxy together around you while you drift towards sleep. Dark matter halos are among the most magnificent structures in the universe, though you will never see one. Every galaxy, including our own Milky Way, is embedded within a vast, roughly spherical cloud of dark matter that extends far beyond the visible edge of the galaxy. The Milky Way's dark matter halo is estimated to be several times larger in diameter than the luminous disk of stars we see in the night sky. It is this halo that provides the gravitational framework within which the galaxy's stars orbit, its gas clouds condense, and its spiral arms maintain their elegant shape. You can think of it as the invisible cocoon within which the visible galaxy lives and breathes. And you can think of your own unconscious mind in a similar way. A vast, unseen envelope of processes and potentials that surrounds and supports the small, bright center of your conscious awareness. You are always larger than you think you are. The visible part of you is just the beginning. One of the most extraordinary things about dark matter is that it does not interact with itself in the way ordinary matter does. When two clouds of gas collide, they heat up, they compress, they radiate energy, they slow down. But when two clouds of dark matter pass through each other, they simply keep going, like two populations of ghosts walking through each other in an empty hall. This is why, in the bullet cluster collision, the dark matter separated so cleanly from the hot gas. It does not feel electromagnetic forces. It does not generate friction. It does not glow or cool or stick. It moves through the universe with a kind of serene indifference, interacting only through gravity, the most gentle and far-reaching of all forces. There is something deeply calming about this image. Dark matter does not struggle. It does not resist. It simply is. And in being, it holds everything together. Perhaps tonight, there is a lesson in that, a reminder that the deepest forms of strength are often the quietest. Axions are another candidate for dark matter, lighter and more elusive even than WIMPs. Originally proposed in the late 1970s to solve a different problem in particle physics. A puzzle about why the strong nuclear force respects certain symmetries. Axions turned out to have just the right properties to be dark matter particles. They would be extraordinarily light, perhaps 1 trillion times lighter than an electron, and they would be produced in vast quantities in the early universe. If they exist, they would form a kind of fog pervading all of space, a background field so fine and uniform that detecting individual axions would require instruments of almost absurd sensitivity. Several experiments are currently underway to search for axions, including one called ADMX, which uses powerful magnets and resonant cavities to coax these particles into converting into detectable photons. The search for axions is a search for whispers in the dark, a quest to hear the quietest voice in the universe. There is a concept in neuroscience called neural dark energy, introduced by researchers who noticed that the brain expends an enormous amount of energy on activity that has no obvious connection to the tasks a person is consciously performing. When you sit quietly, doing nothing, thinking of nothing in particular, your brain does not go idle. It continues to consume nearly as much energy as it does when you are solving a complex problem or reading a difficult book. This baseline activity, carried out largely by the default mode network, accounts for the vast majority of the brain's energy budget. Researchers called it neural dark energy because, like its cosmic counterpart, it is an enormous expenditure of resources whose purpose is not fully understood. It may be involved in consolidating memories, simulating future scenarios, maintaining your sense of self, or simply keeping the neural architecture primed and ready. Whatever its function, it is a reminder that even in your quietest moments, your brain is doing immense, invisible work. The default mode network is a constellation of brain regions that becomes most active when you are not focused on the outside world, when you are daydreaming, reflecting on the past, imagining the future, or drifting towards sleep. It includes the medial prefrontal cortex, the posterior cingulate cortex, and parts of the temporal and parietal lobes. For a long time, neuroscience largely ignored this network, dismissing its activity as mere noise or background chatter. But in recent decades, researchers have come to understand that the default mode network is anything but idle. It is the brain's dark matter, the hidden infrastructure that supports the self. It is where your sense of identity is maintained, where your autobiographical memories are woven together, where the narrative of your life is quietly written and rewritten. As you lie here tonight, the default mode network is gently humming, stitching together the threads of your day, preparing the fabric of your dreams. You do not need to direct it. It knows what to do. In the vast emptiness between galaxy clusters, there exist regions known as cosmic voids, immense stretches of space, sometimes hundreds of millions of light years across, where almost nothing exists. No galaxies, no stars, no visible matter, just darkness and a thin, diffuse mist of dark matter and dark energy. These voids are not failures of the universe. They are an essential part of its structure, the empty spaces that define the web, just as the silence between notes defines a melody. Without the voids, there would be no filaments, no clusters, no architecture at all. And in the same way, the quiet spaces in your mind, the pauses between thoughts, the stillness between breaths, the emptiness that opens up as you approach sleep, are not absences. They are architecture. They are the voids that give shape to your inner cosmos, the silences that allow meaning to emerge. Do not be afraid of the emptiness tonight. It is the space in which everything is held. As we reach the end of this first passage through the invisible scaffold of the universe and the mind, let yourself feel the weight of what we have explored together. We have followed Vera Rubin into the spinning darkness of galaxies and emerged with a question that still has no final answer. We have seen how dark matter, though invisible and untouchable, provides the gravitational framework for everything that exists, every star, every planet, every thought you have ever had. We have discovered that the cosmic web and the neural web share the same mathematical grammar, that gravitational lenses and subconscious biases bend reality in hauntingly similar ways, and that the search for dark matter particles is a mirror of the brain's own search for meaning in the dark. None of this requires your effort tonight. It asks only for your presence. The universe is holding itself together around you. Your mind is doing the same. And in the space between the visible and the invisible, between waking and sleep, there is a stillness that belongs to both the cosmos and to you. Rest in it. Let it carry you. We have spoken of the invisible glue that holds the universe together, the dark matter that binds galaxies and shapes the cosmic web. But there is another force at work in the cosmos, one that does not pull but pushes, one that does not gather but scatters, and it is even more mysterious than dark matter. It is called dark energy, and it accounts for roughly 68% of the total energy content of the universe. If dark matter is the skeleton of the cosmos, dark energy is the breath that inflates it, a relentless outward pressure woven into the very fabric of space itself. Together, dark matter and dark energy make up approximately 95% of everything that exists. The atoms you are made of, the light you see by, the warmth you feel, all of it is a thin residue, a 5% shimmering on the surface of an ocean whose depths are entirely invisible. Tonight, you are resting in that ocean, and it is expanding around you as you breathe. The discovery of dark energy came as a shock to the scientific world. In 1998, two independent teams of astronomers were studying distant supernovae, the brilliant explosions of dying stars, to measure the rate at which the expansion of the universe was slowing down. Everyone expected the expansion to be decelerating because gravity, the attractive force of all the matter in the cosmos, should be pulling everything back together like a ball thrown into the air, gradually losing speed. But the supernovae were dimmer than expected, which meant they were farther away than the models predicted, which meant the universe was not slowing down at all. It was speeding up. The expansion of the universe was accelerating, driven by some unknown energy that pervaded all of space. The discovery earned Saul Perlmutter, Brian Schmidt, and Adam Rees the Nobel Prize in Physics, and it left cosmology with its deepest unanswered question. What is dark energy, and why is it tearing the universe apart? There is a profound tension at the heart of the cosmos, a tug-of-war between two invisible giants. On one side stands dark matter, pulling galaxies together, building structure, creating the filaments and clusters and walls of the cosmic web. On the other side stands dark energy, pushing space apart, stretching the distances between galaxy clusters, thinning the web, accelerating the emptiness. For billions of years, dark matter had the upper hand. The early universe was dense enough that gravity could overcome the expansion, gathering matter into the first stars and galaxies. But as the universe expanded and matter spread thinner, dark energy gradually gained dominance. Today, it is winning. The expansion is accelerating, and the voids between galaxy clusters are growing wider and colder with every passing moment. And yet, within the galaxies themselves, dark matter still holds firm, a quiet guardian resisting the tide. You can feel this tension in your own life, the pull of connection and the push of solitude, the desire to gather close and the need to expand into the unknown. Think of your mind as a small universe, and you will find the same two forces at work. There is a part of you that draws inward, that seeks coherence, that wants to hold your memories and beliefs and relationships together in a stable structure. This is your psychological dark matter, the gravitational center of your identity. And there is another part that pushes outward, that questions, that dissolves old certainties, that creates space between who you were and who you are becoming. This is your psychological dark energy, the expansive force that makes growth possible. Neither force is good or bad. Neither is the enemy of the other. They are partners in an eternal dance, and the shape of your inner universe at any given moment is determined by the balance between them. Tonight, as you approach sleep, the expanding force grows gentle, and the gathering force grows strong. Your thoughts draw inward. Your awareness contracts to a single, quiet point. And in that contraction, there is peace. Every galaxy in the universe is wrapped in an invisible cocoon of dark matter known as a halo. These halos are not thin shells or delicate membranes. They are immense, diffuse clouds of dark matter that extend far beyond the visible boundaries of the galaxy they contain. The Milky Way's halo, for instance, stretches roughly 300,000 light-years from the galactic center, while the visible disk of stars spans only about 100,000 light-years. The halo is the true body of the galaxy, and the luminous disk of stars and gas that we see in photographs is merely the bright core nestled within it. It is the halo's gravity that keeps the galaxy's outer stars in orbit, prevents its spiral arms from unwinding, and shields it from being torn apart by the tidal forces of neighboring galaxies. The halo is a protector, silent and vast, holding everything together from the outside in. Your mind has its own halo, a set of core beliefs, deep assumptions, and foundational narratives that surround and stabilize your conscious experience. You are rarely aware of these structures, just as you are rarely aware of the dark matter halo surrounding the Milky Way, but they are always there, quietly shaping the way you interpret events, the way you respond to stress, the way you understand your place in the world. These core beliefs were formed early in your life, laid down in childhood like the dark matter halos that formed in the early universe, and they have been exerting their gravitational influence ever since. Some of them serve you well, holding your identity together with quiet strength. Others may distort your perception, bending the light of experience the way a gravitational lens bends starlight. But tonight, you do not need to examine them or challenge them. Tonight, they are simply there, a vast, invisible cocoon holding you steady as you drift. Let them do their work. You are safe inside your halo. One of the strangest implications of modern physics is that empty space is not truly empty. Even in the most perfect vacuum, stripped of every atom and every photon, space itself retains a baseline energy, a faint, irreducible hum known as vacuum energy or zero-point energy. This energy arises from quantum mechanics, from the fact that even in the ground state, the lowest possible energy level, particles and fields continue to fluctuate. Virtual particles blink in and out of existence in fractions of a second, borrowing energy from the vacuum and returning it almost instantly. The vacuum is not still. It seethes with potential, a restless ocean of creation and annihilation, happening at scales too small to see, but too fundamental to ignore. Some physicists believe that vacuum energy is the source of dark energy, that the expansion of the universe is driven by this quantum restlessness woven into the fabric of space itself. There is a powerful parallel here to the nature of silence in the human mind. When you close your eyes and the room grows still, when the last thought seems to fade and you feel as though your mind has gone quiet, you have not reached emptiness. You have reached the mental equivalent of the quantum vacuum, a state that appears still but is alive with potential. Beneath the surface of conscious silence, your neurons continue to fire. Your default mode network hums along, processing memories, rehearsing futures, maintaining the delicate architecture of the self. Dreams are forming in the depths, like virtual particles flickering in the void. The silence you feel at the edge of sleep is not the absence of activity. It is the presence of a deeper kind of activity, one that does not need your attention or your effort. You are not falling into nothing tonight. You are falling into a field of infinite potential, a silence that is full. The cosmological constant, first introduced by Albert Einstein in 1917 and later abandoned by him as his greatest blunder, has returned to haunt modern physics. Einstein added the constant to his equations of general relativity to prevent the universe from collapsing under its own gravity, creating a static, unchanging cosmos. When Edwin Hubble discovered that the universe was expanding, Einstein dropped the constant, embarrassed by what he saw as an unnecessary complication. But decades later, when the accelerating expansion was discovered, physicists realized that something very much like the cosmological constant was needed after all, a term representing a constant energy density filling all of space, pushing it apart. The irony is exquisite. Einstein's greatest blunder may have been calling it a blunder. The universe, it seems, has a sense of poetry that even its greatest minds cannot always anticipate. The cosmological constant poses one of the most embarrassing problems in all of theoretical physics. When physicists try to calculate the expected value of vacuum energy using quantum field theory, the number they get is approximately 120 orders of magnitude larger than the value we actually observe. This is not a small discrepancy. It is the largest mismatch between theory and observation in the history of science. If the vacuum energy were truly as large as quantum mechanics predicts, the universe would have been torn apart in its first moments, and nothing, no galaxies, no stars, no planets, no life would ever have formed. The fact that the cosmological constant is not zero but is extraordinarily small, just enough to accelerate the expansion without destroying the cosmos, is one of the deepest mysteries we face. Some call it fine-tuning, others call it a coincidence, and some see it as a clue that our understanding of reality is still profoundly incomplete. Let that incompleteness comfort you tonight. The universe does not have all the answers either. In the first fraction of a second after the Big Bang, something extraordinary happened. The universe, already expanding, suddenly underwent a period of exponential growth known as cosmic inflation. In a time span shorter than the blink of an eye, roughly 10 to the minus 36 seconds to 10 to the minus 32 seconds, the universe expanded by a factor of at least 10 to the 26th power. A region smaller than a proton was stretched to a size larger than the observable universe today. Inflation smoothed out the wrinkles in space-time, flattened the geometry of the cosmos, and seeded the tiny quantum fluctuations that would eventually grow into galaxies and clusters. It was the most dramatic transformation in the history of existence, a moment when the very nature of space was rewritten, when potential became structure, when the formless became the formed. There is a beautiful analogy between cosmic inflation and the moments of sudden insight that transform the human mind. You have experienced this, a long period of confusion or struggle, a problem that resists all conscious effort, and then, without warning, a flash of understanding that reorganizes everything. Psychologists call these moments insight experiences. Neuroscientists have observed that they are preceded by a burst of gamma wave activity in the brain, a sudden synchronization of neural firing that cuts through the noise like a signal emerging from static. In an instant, the mental landscape expands. Connections that were invisible become obvious. The architecture of understanding inflates, and what was once formless and chaotic suddenly has shape and meaning. These moments are the mind's version of cosmic inflation, brief, explosive, and irreversible. After them, nothing looks the same. And perhaps, tonight, as your mind releases its grip on the day, a small inflation is happening in the quiet, a subtle reorganization of everything you have learned and felt, preparing you for the clarity that comes with morning. Dark energy does not only push the universe apart, it also determines the ultimate fate of the cosmos. If dark energy remains constant at its current strength, the universe will continue to expand forever, and the expansion will accelerate without limit. Over billions of years, galaxies beyond our local group will recede beyond the observable horizon, their light redshifted into invisibility. The night sky will grow darker. Stars will exhaust their fuel and die, one by one. White dwarfs will cool into black dwarfs. Black holes will slowly evaporate through Hawking radiation. And eventually, in the unimaginably distant future, the universe will reach a state of maximum entropy, a condition of perfect uniformity, perfect stillness, and near absolute cold. Cosmologists call this the heat death of the universe, or the Big Freeze. It is the ultimate sleep, a stillness so complete that not even time, in any meaningful sense, continues to pass. The Big Freeze is not a violent end. It is not a collapse or an explosion. It is a slow, gentle exhalation, a universe breathing out for the last time and never breathing in again. And there is something strangely peaceful about this image, if you let it settle. All the turbulence of creation, the supernovae, the colliding galaxies, the birth and death of stars will eventually give way to a silence so deep and so total that it becomes indistinguishable from perfection. The universe will not end in agony. It will end in rest. And tonight, on a much smaller and much warmer scale, you are enacting your own version of this process. Your body is cooling. Your heart is slowing. Your thoughts are thinning and spreading apart, like galaxies in an expanding cosmos. You are not dying. You are approaching your own nightly equilibrium, your own personal big freeze, the still point at the center of sleep, where everything is quiet and nothing needs to happen. There is another possible fate for the universe, more dramatic and more unsettling than the big freeze. If dark energy is not constant, but instead grows stronger over time, the expansion of the universe will accelerate beyond all bounds. In this scenario, known as the Big Rip, dark energy will eventually overcome every force in nature, first tearing apart galaxy clusters, then galaxies, then solar systems, then planets, then atoms, then the very fabric of space-time itself. Everything that exists will be shredded into an infinite, formless expanse. The Big Rip is the opposite of the Big Freeze. Not a gentle fading into silence, but a violent dissolution of all structure. Current observations suggest that this scenario is unlikely, that dark energy appears to be roughly constant, but the possibility remains, a reminder that the universe's future, like our own, is not entirely certain, and there is a strange freedom in that uncertainty. Not knowing how the story ends means the story is still being written, yours included. The concept of the expanding universe has a curious parallel in the psychology of personal growth. As you move through life, your inner universe expands. New experiences, new relationships, new ideas push the boundaries of who you are, stretching the space between your old self and your new one. This expansion can feel uncomfortable, even frightening, like the galaxies being pulled apart by dark energy. The familiar grows distant, the known recedes, and yet this expansion is not destruction. It is the creation of new space for new thoughts, new emotions, new ways of understanding yourself and the world. The voids that open up inside you when old certainties fall away are not empty. They are pregnant with possibility. Just like the cosmic voids between galaxy clusters, which are not absences, but structural elements of the universe's architecture. Growth requires expansion. Expansion requires letting go. And letting go, tonight, is the easiest thing in the world. You simply stop holding on, and the universe does the rest. In the late 1990s, astronomers began to map the distribution of dark matter in galaxy clusters using a technique called weak gravitational lensing. Unlike strong lensing, which produces dramatic arcs and multiple images, weak lensing causes only a slight, statistical distortion in the shapes of background galaxies, a gentle stretching that is invisible in any single galaxy, but becomes detectable when thousands of galaxies are analyzed together. By measuring these tiny distortions across vast regions of sky, scientists could reconstruct the distribution of dark matter like a doctor reading an X-ray of a patient they cannot see. The resulting maps were breathtaking. Vast clouds of dark matter, clumpy and filamentary, tracing the same cosmic web that computer simulations had predicted. For the first time, the invisible skeleton of the universe had been imaged, not through light, but through the subtle bending of light by gravity. There is a technique in psychology not unlike weak gravitational lensing. When a therapist listens to a person speak, they are not only hearing the words, they are reading the subtle distortions in the person's narrative, the slight bending of emphasis, the unconscious repetition of certain themes. the gravitational pull of unspoken fears that curve the story in ways the speaker does not notice. No single sentence reveals the hidden structure, but across many sessions, across many stories, the pattern emerges, and the therapist begins to see the invisible architecture of the person's inner world. This is the art of listening for what is not said, of mapping the dark matter of the psyche through its effects on the visible. And tonight, as you rest, your own mind is performing a similar act of quiet reconstruction, sifting through the day's events, noting the subtle distortions, and gently reshaping the map of who you are. The interaction between dark matter and dark energy creates a rhythm in the history of the universe, a vast cosmic breathing. In the early universe, when matter was dense and space was small, dark matter's gravitational pull dominated. Structure formed, galaxies were born, the cosmic web grew thick with filaments and clusters. This was the universe's inhalation, a great gathering of matter and energy into form. But as the universe expanded and dark energy gained strength, the gathering slowed, then stopped, then reversed. The voids began to grow, the filaments began to thin. The space between clusters widened into chasms of cold emptiness. This is the universe's exhalation, a slow release that will continue for trillions of years. You are alive during the transition, the moment between the inhale and the exhale, when structure still exists but the breath is already turning outward. And your own breath tonight mirrors this cosmic rhythm, a gathering in, a letting go, a gathering in, a letting go until the boundary between your breath and the breath of the universe dissolves entirely. Redshift is the phenomenon by which light from distant galaxies is stretched to longer, redder wavelengths as the space between us and those galaxies expands. The farther away a galaxy is, the more its light is redshifted, because the light has traveled through more expanding space to reach us. This is not because the galaxies are moving through space away from us, but because space itself is growing, carrying the galaxies along with it, like raisins in a rising loaf of bread. Redshift is the fingerprint of cosmic expansion, and it was the first clue that the universe is not static but dynamic, not eternal and unchanging but born and evolving. When you look at a distant galaxy and see its light shifted toward the red, you are seeing the universe's expansion written in color. You are watching the breath of the cosmos stretched across the electromagnetic spectrum, a slow exhalation encoded in photons that have been traveling for billions of years. There is a kind of redshift that happens in the mind as memories age. A vivid experience, sharp and immediate when it first occurs, gradually loses its intensity over time. The colors fade, the details blur, the emotional charge diminishes, stretched thin by the expanding distance between the present moment and the moment of the memory's creation. This is not forgetting. It is a natural process of psychological expansion, a way the mind creates space between itself and its past so that it can continue to grow. The redshift of memory is a mercy. Without it, every painful experience would remain as vivid as the moment it happened, and the mind would be crushed under the weight of its own history. Instead, the light of old memories gently dims, shifting toward the softer end of the emotional spectrum, allowing you to carry the past without being consumed by it. Tonight, let your memories redshift. Let them drift toward the quiet edge of awareness, their light grown soft and warm, no longer burning but glowing, like the ancient light of a galaxy at the edge of the observable universe. In 2005, a team of researchers using the Hubble Space Telescope created the deepest image of the universe ever taken, known as the Hubble Ultra Deep Field. They pointed the telescope at a tiny, seemingly empty patch of sky, a region no larger than a grain of sand held at arm's length, and let it collect light for nearly 12 days. What emerged from that apparently empty darkness was astonishing. Approximately 10,000 galaxies stretching back to within a few 100 million years of the Big Bang. Each galaxy contained billions of stars. Each star potentially harbored planets, and this was just one tiny grain of the sky. The image revealed that the universe is unimaginably vast, unimaginably populated, and unimaginably deep. And all of it, every galaxy in that image, was embedded in a sea of dark matter and swept along by the current of dark energy. The emptiness was an illusion. There is no such thing as empty space. And there is no such thing as an empty mind. When you close your eyes and the world falls away, when the noise of the day fades and you feel as though you are floating in nothing, you are not in nothing. You are in the Hubble Ultra Deep Field of your own consciousness, a darkness that, if you could look deeply enough and long enough, would reveal 10,000 memories, 10,000 emotions, 10,000 unspoken thoughts, all drifting in the vast inner space of your awareness. The darkness behind your eyelids is not void, it is full. It is the richest, most populated landscape you will ever encounter, and it is entirely yours. Tonight, you do not need to explore it. You do not need to catalogue its contents or map its boundaries. You only need to rest inside it, trusting that the invisible structures are holding, that the dark matter of your mind is doing its quiet, patient work, and that when you wake, the light will return to a universe that was never truly dark. The Sunyaev-Zeldovich effect is a subtle phenomenon in which photons from the cosmic microwave background are scattered by hot electrons in galaxy clusters, gaining energy and shifting to shorter wavelengths as they pass through. This effect allows astronomers to detect massive galaxy clusters at great distances, even when those clusters are too faint to see directly in visible light. More importantly, by combining the Sunyaev-Zeldovich effect with gravitational lensing measurements, scientists can estimate the total mass of a cluster, both visible and dark, and compare it to the mass inferred from the cluster's hot gas alone. The discrepancy, once again, points to dark matter. Vast reservoirs of invisible mass that outweigh the visible components by a factor of roughly 5 to 1. Every new method of observation confirms the same quiet truth. The universe is mostly hidden, and the hidden part is the part that matters most. As we approach the midpoint of this journey through the dark universe and the dreaming mind, let us pause here in the expanding silence. We have felt the push of dark energy and the pull of dark matter, the cosmic tug-of-war that gives the universe its shape and its fate. We have rested inside galactic halos and floated through the quantum hum of vacuum energy. We have witnessed the sudden inflation of space and the slow redshift of ancient light. And through it all, we have seen mirrors. The expanding boundaries of personal growth, the quiet scaffolding of core beliefs, the redshift of aging memories, the deep field of the sleeping mind. The universe is not out there. It is in here. It is the pattern that repeats at every scale, from the cosmic web to the neural web, from the vacuum of space to the silence between your thoughts. You are halfway home now. The breath of the cosmos is slowing around you, Let it carry you further. Let it carry you deeper. There is still so much invisible beauty to explore, and all of it is waiting for you in the dark. Somewhere beneath the Black Hills of South Dakota, nearly a mile underground in a cavern carved from an old gold mine, one of the most sensitive instruments ever built by human hands sits in perfect silence. It is called Lux Zeppelin, or LZ, and its purpose is extraordinary in its simplicity: to wait. The detector is a tank filled with 10 tons of ultra-pure liquid xenon, cooled to -100 degrees Celsius, surrounded by layers of shielding designed to block every known form of radiation. Cosmic rays, gamma rays, neutrons, the faint radioactive whisper of the rock itself. All of this effort, all of this engineering, all of this patience exists for a single hope: that one day, one dark matter particle, drifting through the Earth as billions do every second, will strike a xenon atom and produce a tiny, unmistakable flash of light. The entire experiment is a prayer written in physics. It is a cathedral of waiting, built underground so that the silence is deep enough to hear the universe whisper. Beneath the Gran Sasso mountain in central Italy, another detector pursues the same ghost. It is called XCN ONT, and like its American counterpart, it uses liquid xenon as a target, watching for the faintest scintillation that might betray a dark matter collision. The Gran Sasso National Laboratory sits under nearly a mile of solid rock, which acts as a natural shield against the constant bombardment of cosmic rays that rain down from space. Even so, the researchers must contend with background noise from every conceivable source: radioactive decay in the detector materials, radon gas seeping through microscopic cracks, even the faint neutrino flux from the sun. Every signal that is not dark matter must be identified and subtracted, leaving behind only the irreducible silence in which a true detection might be heard. The scientists who work here have spent years learning to listen to nothing, refining their instruments until the noise floor drops to nearly zero, and then listening still more carefully. Liquid xenon was chosen for these experiments, not by accident, but by a convergence of beautiful physical properties. Xenon is a noble gas, chemically inert, reluctant to bond with anything, which makes it possible to purify to an almost supernatural degree. When cooled to a liquid, it becomes dense and transparent, an ideal medium for detecting the faint signals of particle interactions. When a particle strikes a xenon atom, two things happen almost simultaneously: a flash of scintillation light and a release of electrons, which drift through the liquid under the influence of an electric field and produce a second flash when they reach the gas phase above. By measuring the timing and intensity of both flashes, scientists can determine the energy, location, and type of the interaction with remarkable precision. The detector does not simply wait for a signal. It reads the signal's fingerprint, distinguishing the gentle touch of a dark matter particle from the heavier hand of ordinary radiation. There is something deeply meditative about the act of building an experiment designed to detect the nearly undetectable. The researchers who construct these machines must cultivate a patience that borders on the spiritual. They spend years designing, building, calibrating, and then they wait, sometimes for years more, accumulating data in the darkness, searching for a signal that may never come. Every component of the detector is selected for its radio purity, tested for contamination at the level of parts per trillion. The xenon itself is circulated through purification systems continuously, removing even the faintest traces of krypton and radon. The result is a volume of matter more pristine than almost anything else on Earth. A stillness so refined that a single atomic event can be heard above the silence. This is what it means to listen to the universe with your full attention. This is what it means to be truly quiet. And perhaps tonight, as you lie in the dark, you can think of yourself as a kind of detector. Your body is still. The room is quiet. The noise of the day is being filtered away, layer by layer, like the cosmic rays being absorbed by a mile of rock. Your thoughts are the background radiation, persistent, familiar, but gradually fading as sleep approaches. And somewhere beneath all of that noise, beneath the mental chatter and the residual tension and the last traces of the day's concerns, there is a signal. It is the signal of your own deepest rest, the quiet hum of a nervous system returning to its baseline, the faint flash of the brain crossing the threshold from waking to sleep. You do not need to search for it. You do not need to strain to hear it. You only need to make the silence deep enough, and the signal will find you. The axion is a particle that was not originally proposed to explain dark matter at all. It was born from a puzzle in quantum chromodynamics, the theory that describes the strong nuclear force, the force that holds the nuclei of atoms together. This puzzle, known as the strong CP problem, asks why the strong force respects a certain symmetry that it has no obvious reason to respect. In 1977, Roberto Peccei and Helen Quinn proposed a mechanism that would naturally enforce this symmetry, and shortly after, Frank Wilczek and Steven Weinberg independently realized that this mechanism implied the existence of a new, extremely light particle. Wilczek named it the axion, after a brand of laundry detergent, because it cleaned up a messy problem in physics. The name was playful, but the implications were profound. If axions exist, they could be produced in staggering quantities in the early universe, forming an invisible fog that pervades all of space, a candidate for dark matter hiding in plain theory. Unlike WIMPs, which are heavy and interact through the weak nuclear force, axions would be almost incomprehensibly light, perhaps a billionth of the mass of an electron, or even less. At such tiny masses, axions would behave less like particles and more like waves, oscillating coherently across vast stretches of space, like a single, sustained note played on an instrument too large to see. Detecting such a particle requires an entirely different approach than the xenon detectors use. The leading experiment, called ADMX, the Axion Dark Matter E-experiment, uses a powerful superconducting magnet and a resonant microwave cavity to convert axions into photons, real, detectable particles of light. The cavity is tuned to different frequencies, like a radio dial being slowly turned across the spectrum, listening for the one precise frequency at which the axion field resonates. It is, in the most literal sense, a search for a single note in a cosmic hurricane, a whisper so faint that the entire apparatus must be cooled to temperatures colder than outer space to hear it. The patience required to search for axions is almost incomprehensible. The ADMX experiment has been running in various forms since the 1990s, slowly scanning through a range of possible axion masses, one narrow frequency band at a time. Each band requires hours or days of data collection to achieve the sensitivity needed to detect or rule out the axion signal at that frequency. The total range of plausible axion masses spans many orders of magnitude, and covering all of it could take decades. And yet the researchers persist, motivated by the elegance of the theory and the tantalizing possibility that dark matter, the most abundant substance in the universe, might reveal itself not as a heavy particle crashing into a xenon atom, but as a gossamer wave, whispering through a magnetic field. There is a lesson in this persistence, a quiet reminder that the most important truths are often the ones that take the longest to find, and that the willingness to wait is itself a form of wisdom. The idea that dark matter might consist of a single type of particle, whether a WIMP or an axion, may be an oversimplification. Some physicists have proposed that dark matter is not a lone species, but an entire dark sector, a hidden ecosystem of particles and forces as rich and varied as the visible matter we know. In this picture, there could be dark electrons, dark protons, dark photons, particles that interact with each other through dark forces, but remain invisible to our instruments because they do not couple to ordinary light or matter. There could be dark atoms, dark chemistry, even dark structures. The dark sector might have its own complexity, its own elegance, its own forms of organization, all of it coexisting with our visible universe like two cities built on the same ground, each invisible to the other. We would never know, because the only bridge between the two worlds is gravity, and gravity tells us only that the mass is there, not what it looks like or how it behaves. The possibility of a dark sector is both humbling and exhilarating. If true, it would mean that the universe we see, the stars, the elements, the chemistry of life, is just one expression of nature's creativity. There would be another expression, equally vast, equally complex, occupying the same space, but forever beyond our direct reach. We would be like fish in the ocean, aware of the water and the creatures within it, but oblivious to the sky, the air, the birds, the entire atmosphere of phenomena occurring just above the surface. The dark sector hypothesis reminds us that reality may be layered in ways we have not imagined, that the invisible is not necessarily simple, and that the universe may be far stranger and more beautiful than even our boldest theories suggest. Tonight, let that possibility drift through your mind like a slow current. There may be more to everything than you have ever been told. And that is not frightening. It is wonderful. In 2015, the LIGO Observatory detected gravitational waves for the first time, ripples in the fabric of space-time, caused by the collision of two black holes more than 1 billion light-years away. This detection opened a new window on the universe, one that does not rely on light, but on the vibration of space itself. Some physicists have proposed that gravitational wave detectors could eventually be used to search for dark matter as well. Certain models predict that dark matter could form compact objects, primordial black holes, for instance, created not from dying stars, but from density fluctuations in the early universe. If these objects exist, their mergers would produce gravitational waves with a distinctive signature, different from those produced by ordinary astrophysical black holes. The search for dark matter, already conducted underground and in magnetic cavities, may one day extend to the detection of tremors in the geometry of space, felt across the cosmos like the vibration of a bell struck in the dark. Primordial black holes are one of the more exotic candidates for dark matter. Unlike the stellar black holes formed when massive stars collapse, Primordial black holes would have been created in the first fraction of a second after the Big Bang, when the density of the universe was so extreme that small fluctuations in the distribution of energy could have caused pockets of space to collapse directly into black holes. These objects could range in mass from less than a gram to thousands of times the mass of the Sun. And if they exist in sufficient numbers, they could account for some or all of the dark matter we observe. The idea is elegant in its simplicity. Dark matter might not be a new kind of particle at all. It might be ordinary gravity, locked inside objects so dense and so dark that they are indistinguishable from the void. The universe's greatest mystery might be hiding not in the quantum foam, but in the oldest and most familiar force of all. The search for dark matter is not confined to the Earth. Space-based experiments like the Alpha Magnetic Spectrometer, mounted on the International Space Station, scan the cosmic rays streaming through space for anomalies that might betray the presence of dark matter. When dark matter particles collide with each other in the halos of galaxies, they might annihilate, producing bursts of ordinary particles, positrons, antiprotons, gamma rays that would stand out against the background of cosmic radiation. The Alpha Magnetic Spectrometer has detected an excess of positrons at certain energies that is consistent with dark matter annihilation, though other explanations, such as nearby pulsars, cannot yet be ruled out. The ambiguity is maddening and beautiful in equal measure. The signal is there, faint and tantalizing, but the noise of the universe has not yet been peeled back far enough to reveal it with certainty. The search continues, high above the atmosphere, in the cold silence between the stars. The Fermi Gamma Ray Space Telescope has also joined the hunt, scanning the sky for gamma rays that might be produced when dark matter particles annihilate in regions of high density, the centers of galaxies, the cores of dwarf spheroidal galaxies, the dense knots of the cosmic web. In 2009, researchers reported a mysterious excess of gamma rays emanating from the center of the Milky Way, a glow that could not be fully explained by known astrophysical sources. Some interpreted this as a possible signal of dark matter annihilation, a faint light produced by invisible particles destroying each other in the gravitational furnace at the heart of our galaxy. Others suggested more mundane explanations, a population of unresolved pulsars, for instance. The debate has continued for over a decade, and the galactic center excess remains one of the most intriguing unsolved puzzles in dark matter research. The signal flickers at the edge of certainty, like a candle seen through fog. The struggle to separate signal from noise is perhaps the defining challenge of dark matter physics, and it carries a profound metaphor for the inner life of the mind. Every detector, whether it sits underground or orbits in space, must contend with an overwhelming flood of irrelevant data, cosmic rays, radioactive decays, instrumental artifacts, atmospheric interference. The true signal, if it exists, is buried beneath layers of noise so thick that extracting it requires years of careful analysis and the elimination of every known source of confusion. This is remarkably similar to the challenge you face every night as you try to fall asleep. The signal, the quiet call of rest, the body's readiness for sleep is always there, but it is buried beneath the noise of worry, of planning, of replaying the day, of anticipating tomorrow. The art of falling asleep, like the art of dark matter detection, is the art of reducing noise until the signal can be heard. There is a practice in contemplative traditions that mirrors this scientific process almost exactly. Meditators are taught to observe their thoughts without engaging them, to let mental chatter rise and fall without grasping or resisting, to gradually reduce the noise of the conscious mind until a deeper silence emerges. This silence is not emptiness. It is clarity. It is the mental equivalent of a detector with its background noise reduced to near zero. A mind so still that the faintest signal, a shift in awareness, a deepening of presence, the first stirring of sleep can be felt with exquisite sensitivity. You do not need to be a practiced meditator to experience this tonight. You only need to let the thoughts pass without following them, to treat each one as a stray cosmic ray passing through the detector, noted and released. The signal beneath them is patient. It has been waiting for you all day, and it will find you the moment you stop looking for it. The concept of background radiation, both cosmic and psychological, deserves its own contemplation. The cosmic microwave background is a remnant of the Big Bang, a bath of ancient photons that fills all of space with a faint, nearly uniform glow. It is the noise of creation itself, the afterglow of the moment when the universe became transparent to light. Every detector that searches for dark matter must account for this background, must subtract it from the data to reveal what lies beneath. In the same way, your mind carries its own background radiation, a constant hum of low-level awareness, a baseline of sensation and thought that persists even in your quietest moments. This is not a flaw. It is the afterglow of consciousness, the remnant of a mind that has been processing information since the moment it formed. You cannot eliminate it, and you do not need to. You only need to recognize it for what it is, the background, not the signal, and let it be. Neutrinos offer an instructive contrast to dark matter particles. Like dark matter, neutrinos are nearly invisible. They are produced in vast quantities by nuclear reactions in the sun, by supernovae, and by radioactive decays on Earth. Trillions of neutrinos pass through your body every second without interacting. For decades, they were considered possible dark matter candidates, but neutrinos move too fast. Their velocities, close to the speed of light, would prevent them from clumping together gravitationally to form the structures we observe. Dark matter must be cold, slow-moving, relative to the speed of light in order to collapse under its own gravity and build the cosmic web. This requirement, known as the cold dark matter paradigm, rules out neutrinos and any other particle that moves too quickly. The dark matter we seek is not a fleeting visitor. It is something that lingers, that gathers, that stays, like the deep, slow thoughts that settle in the mind just before sleep. Dark matter is patient and unhurried. The distinction between hot dark matter and cold dark matter is one of the most important in cosmology. Hot dark matter, like neutrinos, moves at relativistic speeds and smooths out small-scale structure, preventing the formation of galaxies and clusters. Cold dark matter moves slowly, allowing gravity to pull it into dense clumps that serve as the seeds for galaxy formation. Observations of the cosmic microwave background, the distribution of galaxies, and the structure of the cosmic web all point overwhelmingly to cold dark matter as the dominant form. The universe's structure, from the largest superclusters to the smallest dwarf galaxies, is best explained by a model in which dark matter is cold, collisionless, and gravitationally dominant. This is the lambda CDM model, lambda for the cosmological constant representing dark energy, CDM for cold dark matter, and it is the standard model of cosmology, the framework within which nearly all modern observations are interpreted. There is a quiet beauty in the Lambda CDM model's simplicity. With just 6 parameters, the density of ordinary matter, the density of dark matter, the density of dark energy, the amplitude and tilt of primordial fluctuations, and the optical depth of reionization, it can describe the entire observable universe from the cosmic microwave background to the present day. 6 numbers, and the whole cosmos unfolds. And yet, within that simplicity lies an enormous mystery. We do not know what dark matter is. We do not know what dark energy is. And we do not understand why the 6 parameters have the values they do. The model works beautifully, but it works like a map drawn by someone who has never visited the territory. The contours are precise, the predictions are accurate, but the landscape itself remains unseen. There is comfort in this paradox tonight. You do not need to understand the territory to trust the map. You do not need to solve the mystery of consciousness to let it carry you into sleep. The human drive to search for the invisible is not a modern invention. It is woven into the deepest layers of our biology. Long before particle physics, long before telescopes and underground detectors, human beings stared into the darkness and wondered what was there. We told stories about spirits and gods, about unseen forces that shaped the weather, the seasons, the movements of the stars. We built temples to the invisible. We composed music that tried to capture what could not be spoken. The scientific search for dark matter is the latest expression of this ancient impulse, a desire to know what lies beyond the reach of the senses, to map the unmappable, to name the unnameable, and the contemplative search for inner peace, for the quiet center of the self, is the same impulse turned inward. We are creatures who cannot stop looking for what is hidden. It is our nature. It is perhaps our purpose. This drive to explore the invisible has a neurological basis. The human brain is wired for curiosity. When we encounter a gap in our knowledge, the brain's reward system activates, releasing dopamine not when the answer is found, but when the question is asked. The act of wondering is itself pleasurable, a neurochemical reward for the willingness to face the unknown. This is why children ask endless questions, why scientists spend decades pursuing particles they may never find, why you lie awake some nights turning a problem over in your mind, not because you expect to solve it, but because the turning itself feels necessary. Curiosity is the mind's gravity. It pulls you toward the unknown, the way dark matter pulls galaxies toward each other. And tonight, you can let that gravity work in your favor. Instead of resisting the unknown of sleep, instead of fearing the loss of control that comes with unconsciousness, you can lean into the curiosity. What will you dream? Where will your mind go when you release it? The unknown is not a threat. It is an invitation. The detectors buried beneath mountains and floating in orbit are, in a sense, extensions of the human nervous system, prosthetic senses designed to perceive what our biological equipment cannot. We built them because evolution did not prepare us for the scale of the universe. Our eyes see a narrow band of the electromagnetic spectrum. Our ears hear a limited range of frequencies. Our hands feel only what is close enough to touch. But our minds, our restless, insatiable minds, refuse to accept these limits. And so we build. We build telescopes to see farther, accelerators to probe smaller, detectors to listen more deeply. Each instrument is a monument to the gap between what we can perceive and what we believe exists, a physical manifestation of the conviction that the universe is larger, stranger, and more beautiful than our senses alone can reveal. Tonight, you can set down these prosthetic senses. You can let the instruments rest. The deepest detector you will ever need is already built. It is your own awareness, and it is tuning itself to the frequency of sleep. The search for dark matter has taught us something that extends far beyond physics. It has taught us that the universe rewards patience, that the most important discoveries often come not from brilliance or speed, but from the willingness to sit quietly in the dark and wait. The scientists who tend these experiments do not expect a breakthrough every day. They expect years of silence, punctuated by the occasional false alarm, followed by more silence. And yet they continue, because the question matters more than the comfort of a quick answer. This is a posture that the sleeping mind understands instinctively. Sleep does not come to those who chase it. It comes to those who create the conditions for it and then wait gently, patiently, without grasping. You have created those conditions tonight. You are lying still. You are breathing slowly. The noise is fading. The detector is ready. Now there is nothing left to do but trust the silence and let the signal come to you in its own time, in its own way, as quiet and certain as gravity. As this third passage draws to a close, we find ourselves deep in the mine shaft of the unknown, surrounded by instruments of extraordinary delicacy, listening for a whisper that may rewrite our understanding of reality. We have descended into gold mines and mountain laboratories. We have cooled liquid xenon to temperatures that would freeze the air in your lungs. We have tuned resonant cavities to hear the song of the axion and scanned the gamma-ray sky for the glow of annihilating dark matter. And in every case, we have found the same truth. The universe asks for patience. It asks us to reduce our noise, refine our silence, and wait with open attention for the signal that is always there, always passing through us, always just beyond the threshold of detection. Your mind is doing this now. It is quieting its instruments, lowering its noise floor, preparing to receive the deepest signal of all the call of sleep. The body's return to stillness, the brain's descent into the restorative dark. You are 3/4 of the way home. The invisible is closer than ever. Let it find you. In the far, far future, so far that the numbers lose their meaning and the mind cannot grasp the distances of time involved, the universe will grow cold. Dark energy, that silent and relentless pressure woven into the fabric of space, will continue to push galaxies apart, stretching the voids between them until no light from one galaxy can ever reach another. The local group, our small family of galaxies bound together by gravity, will merge into a single great elliptical galaxy, and beyond it, nothing. The rest of the universe will have receded past the cosmic horizon, its light redshifted into wavelengths too long to detect, its existence erased from our observable sky. A civilization living in that distant epoch would look up and see only its own galaxy, floating alone in an infinite, featureless darkness, with no evidence that anything else had ever existed. The universe will become a solitude so vast that even the concept of vastness will have no meaning. The stars will be the next to go. Stars burn hydrogen into helium, helium into carbon, carbon into heavier elements, and each generation of stars recycles the materials of the last. But this process is not infinite. The supply of hydrogen in the universe is finite, and as it is consumed, fewer and fewer new stars will form. The last red dwarfs, the smallest and most frugal of stars, will burn for trillions of years, sipping their fuel with extraordinary patience. But even they will eventually exhaust their reserves, their fires dimming to a dull glow before flickering out entirely. When the last red dwarf dies, the age of starlight will be over. The universe will enter an era of darkness, populated only by the cooling remnants of dead stars, white dwarfs fading to black, neutron stars spinning down to silence, and black holes drifting through the void like the final sentinels of a world that once blazed with light. In this dark era, dark matter will remain, long after the last star has burned out, long after the last photon of starlight has been absorbed or redshifted into oblivion. The dark matter halos will persist. They will still surround the remnants of galaxies, still exert their gravitational pull on the dead stars and cooling gas within them. Dark matter does not decay. It does not burn. It does not radiate energy or lose mass to entropy. It is, in a sense, the most enduring substance in the universe, the last scaffold standing in a cosmos that has shed everything else. When the lights go out and the furnaces grow cold, dark matter will still be there, holding the ghostly remnants of galaxies in its invisible embrace. It is the universe's final act of faithfulness, a commitment to structure that outlasts the structures themselves. There is something profoundly reassuring about this image if you allow yourself to sit with it. Even in the deepest cold, even in the most absolute darkness, something holds. The invisible framework does not abandon the universe when the visible beauty fades. It remains patient and silent, a guardian of form in a formless age, and you can carry this image into your own experience of sleep tonight. When the light of consciousness fades, when the vivid imagery of waking life dims and the thoughts grow cold and sparse, something in you will still hold. The deep structures of your brain, the brainstem rhythms, the autonomic cycles, the ancient neural architecture that predates language and thought will continue their quiet work, maintaining the scaffold of your being through the darkness. You are never truly alone in sleep. The invisible is always holding you. The heat death of the universe is the state of maximum entropy, the point at which all energy has been evenly distributed and no gradients remain to drive any process. In thermodynamics, it is the state of perfect equilibrium. No hot spots, no cold spots, no differences of any kind. Without gradients, nothing can happen. No work can be performed. No information can be processed. No change can occur. The universe becomes a vast, uniform sea of particles at the lowest possible energy, a stillness so complete that it is indistinguishable from non-existence, and yet it is not non-existence. It is existence at its most fundamental, stripped of all complexity, all form, all narrative. It is the universe returned to its simplest state, a canvas on which nothing is painted, a silence in which no sound has been forgotten because there is no one left to remember. Entropy is often misunderstood as chaos, but it is more accurately described as the dispersal of energy, the tendency of concentrated energy to spread out and become uniform. A hot cup of tea cools because its heat disperses into the surrounding air. A fire dies because its fuel is consumed and its energy radiates away. The universe as a whole is undergoing this same process on a cosmic scale. Its concentrated energy, the nuclear fires of stars, The gravitational potential of collapsing gas clouds slowly dispersing into the ever-expanding void. The heat death is not the arrival of chaos, it is the arrival of perfect calm. Every process that creates turbulence, every reaction that produces heat and light and motion is a temporary deviation from this ultimate equilibrium. The universe is not falling apart, it is settling down. And tonight, your body is doing the same, releasing the heat of the day, dispersing the concentrated energy of thought and action, settling toward its own nightly equilibrium, its own small heat death, from which you will be gently reborn in the morning. Black holes, those final monuments of collapsed matter, will be among the last objects to persist in the dying universe. But even they are not eternal. Stephen Hawking showed in 1974 that black holes emit a faint thermal radiation, now called Hawking radiation, caused by quantum effects near the event horizon. This radiation carries away energy, and over unimaginably long timescales, the black hole slowly shrinks, losing mass photon by photon until it finally evaporates entirely in a brief burst of particles and light. The largest supermassive black holes, containing billions of solar masses, would take roughly 10 to the 100th power years to evaporate a number so large that writing it out would fill pages. But in the patient arithmetic of eternity, even this is finite. Eventually, the last black hole will evaporate, and the universe will contain nothing but a thin, cooling gas of photons, neutrinos, electrons, and positrons, drifting forever apart in an expanding void. When the last black hole evaporates, the universe will enter what physicists call the dark era, a period of unimaginable duration in which nothing of consequence happens. No stars form, no light shines, no structures exist. The only events are the occasional quantum fluctuation, a brief and random rearrangement of particles that leads nowhere and means nothing. Time, in any physical sense, becomes almost meaningless because there are no processes to mark its passage, no clocks to measure it, no observers to experience it. The arrow of time, which depends on the increase of entropy, loses its direction when entropy has reached its maximum. Past and future become indistinguishable. The universe does not end. It simply ceases to change. And in that cessation, there is a kind of peace that transcends anything we can experience in our brief, turbulent lives. A peace so total that even the concept of peace dissolves into it. The dissolution of time is one of the most profound ideas in all of cosmology. We experience time as a river, flowing in one direction, carrying us from birth to death, from morning to night, from waking to sleep. But time, as physics understands it, is not a river. It is a dimension, and its apparent flow is an artifact of entropy, of the fact that the universe began in a low entropy state and is moving toward a high entropy one. When entropy reaches its maximum, when every gradient has been smoothed and every difference erased, the distinction between past and future vanishes. There is no before and no after. There is only the eternal now, a timeless state that the deepest stages of sleep approximate in miniature. In slow-wave sleep, the brain's sense of time collapses. Minutes can feel like hours, or hours like minutes. The dreaming mind moves through time like a particle through dark matter, without friction, without resistance, without direction. In the deepest stages of non-REM sleep, the brain enters a state of remarkable synchrony. Billions of neurons fire together in slow, rolling waves, oscillating at frequencies of less than 1 cycle per second. These delta waves wash across the cortex like tides across a dark ocean, and in their troughs, the neurons fall nearly silent, entering a state called a down state, a brief period of almost total neural quiescence. During these down states, the cortex is as close to silence as a living brain can get. No sensory information is being processed. No thoughts are being formed. No emotions are being felt. The self, as you know it, has temporarily dissolved. And yet the brain is not dead. It is performing critical maintenance, consolidating memories, clearing metabolic waste, restoring synaptic balance. The silence is not empty. It is regenerative. It is the brain's version of the heat death, a state of perfect equilibrium from which new complexity will emerge when morning comes. The glymphatic system, discovered in 2012, provides a physical mechanism for this nocturnal restoration. During deep sleep, the spaces between brain cells expand by as much as 60%, and cerebrospinal fluid flows through these widened channels, flushing out the metabolic waste products that accumulate during waking hours. Among the substances cleared is beta amyloid, a protein associated with Alzheimer's disease when it builds up in the brain. The glymphatic system is most active during slow-wave sleep, precisely when the brain is at its quietest and the delta waves are at their strongest. Sleep, it turns out, is not merely rest. It is a cleansing, a purification of the neural environment, a process as essential to the brain's health as the purification of liquid xenon is to the dark matter detectors buried beneath the earth. Both systems require silence to function. Both systems do their deepest work in the dark. As the universe approaches its final state of perfect equilibrium, there remains an open question in physics that borders on the mystical. Could it all begin again? Some cosmologists have speculated that a quantum fluctuation in the vacuum, a random, spontaneous rearrangement of energy, could, given enough time, produce a new Big Bang, a new inflation, a new universe blooming from the ashes of the old. The probability of such an event is inconceivably small, but in a timeless void where nothing else can happen, probability has all the patience in the world. The universe may be cyclic, an eternal rhythm of creation and dissolution, expansion and contraction, light and darkness. Or it may not. We do not know. But the possibility is enough to transform the heat death from an ending into a pause, a cosmic sleep from which the universe might one day wake, stretching and yawning into a new dawn of stars. The cyclic model of the universe finds echoes in many of the world's oldest philosophical traditions. The Hindu concept of Brahma's night, the Buddhist wheel of becoming, the Stoic doctrine of eternal recurrence all imagine time not as a line but as a circle, an endless alternation between creation and rest, activity and stillness, being and not being. Modern cosmology cannot confirm or deny these visions, but it has arrived, through mathematics and observation, at a strikingly similar possibility: that the universe breathes, that its expansion and cooling are one long exhalation, and that somewhere in the unimaginable future, a new inhalation may begin. You breathe this way every night. You exhale the day. You cool into stillness. And then, After a period of darkness, you inhale the morning. The rhythm of sleep is the rhythm of the cosmos, enacted in miniature, in the warm and fragile vessel of your body. Dark matter, through all of this, through the birth of stars and their death, through the expansion of space and the evaporation of black holes, through the heat death and the silence that follows, dark matter endures. It does not participate in the drama of nuclear fusion. It does not burn or cool or radiate. It does not decay into lighter particles or dissolve into radiation. It is the most stable, the most patient, the most enduring substance in existence. And in this endurance, it offers a final metaphor for the part of you that persists through every change, every loss, every transformation. There is something in you that does not burn out. There is a core beneath the personality, beneath the emotions, beneath the thoughts that has been present since the beginning of your life and will be present at its end. You cannot see it, you cannot name it, but you can feel it tonight in the stillness, in the space between breaths, in the quiet gravity that holds you together when everything else falls away. The observable universe contains roughly 2 trillion galaxies, each containing hundreds of billions of stars, each star potentially orbited by planets, each planet turning slowly in the gravitational embrace of dark matter halos that are older than the stars themselves. The scale is beyond comprehension. The numbers are beyond imagination. And yet all of it, every galaxy, every star, every planet, every atom of hydrogen and helium and carbon and oxygen, all of it emerged from a single point, a single moment, a single breath of creation that occurred 13.8 billion years ago. You are part of that breath. The atoms in your body were forged in the interiors of stars that died billions of years before the Earth was formed. The dark matter that passes through you tonight was present at the beginning. You are not separate from the cosmos. You are the cosmos, experiencing itself in the form of a human being, lying in the dark, listening to these words, and slowly, gently, returning to the stillness from which all things came. The temperature of the cosmic microwave background is 2.725 Kelvin, less than 3 degrees above absolute zero. This is the temperature of the universe itself, the thermal residue of creation, the faintest possible warmth left over from the Big Bang. It is almost nothing, and yet it is not nothing. It is the universe's lullaby, a hum so low and so constant that it fills all of space, surrounding every galaxy, every star, every planet, every living thing, with a barely perceptible warmth that has been present since the beginning of time. You are bathed in this warmth right now. It is passing through the walls of your room, through your blankets, through your skin. It is the oldest light in existence, and it has been traveling for 13.8 billion years to reach you. Let it reach you. Let it remind you that you have never been outside the universe's embrace, not for a single moment, not for a single breath. The concept of absolute 00 Kelvin, minus 273.15 degrees Celsius, is the temperature at which all thermal motion ceases. No atom vibrates, no molecule rotates, no particle moves. It is the theoretical floor of all physical activity, the point beyond which stillness cannot deepen. No laboratory has ever achieved true absolute zero, because quantum mechanics forbids it. There is always a residual tremor, a zero-point energy that cannot be extracted. But the universe, in its final state, will approach this limit asymptotically, drawing closer and closer to perfect stillness without ever quite reaching it. There will always be a whisper, a faint quantum hum, a last irreducible vibration in the fabric of space. And perhaps that is the most comforting thought of all. Even in the deepest cold, even in the most absolute silence, something remains. Something always remains. In the final epoch of the universe, when the stars have died and the black holes have evaporated and the last photons have redshifted into wavelengths longer than the observable horizon, dark matter will drift through the void in perfect solitude. It will not know that stars once burned. It will not remember that galaxies once spun in great spiraling arms of light. It will simply be present, patient, enduring. And in that endurance, there is no sadness, there is no loss. There is only the quiet continuation of existence in its most fundamental form: mass without light, gravity without fire, presence without performance. Dark matter has never needed to be seen to fulfill its purpose. It has never needed to shine to hold the universe together. And tonight, you do not need to shine either. You do not need to perform or achieve or understand. You only need to be here, now, present in the dark. And that is enough. The human brain, in its deepest sleep, approaches a state that mirrors this cosmic stillness. The cortex falls quiet, the thalamic gates close. The default mode network, which has been gently humming all evening, settles into its lowest mode of activity. The body's temperature drops, the heart rate slows to its minimum, the breath becomes shallow and even, a tide so gentle it barely moves the chest. In this state, you are as close to the stillness of the void as a living being can get, and yet you are alive, profoundly, beautifully alive. Every cell in your body repairing itself, every synapse recalibrating, every memory finding its place in the architecture of the self. The stillness is not the absence of life. It is life at its most essential, stripped of noise, stripped of effort, stripped of everything that is not necessary, and resting in the dark gravity of its own quiet being. There is a theory in physics known as the holographic principle, which suggests that all the information contained within a volume of space can be described by information encoded on its boundary. The universe, in this view, is like a hologram. The three-dimensional reality we experience may be a projection of a deeper, two-dimensional truth written on the surface of the cosmos. If this is correct, then the distinction between inside and outside, between self and universe, between the dreamer and the dream, is not as firm as it appears. You are not a small thing inside a large thing. You are a pattern, a ripple of information, encoded on the boundary of something you cannot see, and projected into the experience of being here, being now, being you. Tonight, let that boundary soften. Let the projection blur. Let the distinction between your body and the bed, between the bed and the room, between the room and the night, between the night and the cosmos, dissolve, slowly, gently, like light fading into the dark. We have traveled far together, from the spinning galaxies of Vera Rubin to the quantum vacuum at the end of time, from the cosmic web to the neural web, from the first light of the Big Bang to the last whisper of a dying black hole. And through it all, one truth has remained constant. The invisible holds the visible. The silence holds the sound. The dark holds the light. You have always known this, not with your mind, but with something deeper, something older, something that does not need words or equations or telescopes to understand. You have known it in the way your body relaxes when the room grows dark, in the way your breath slows when the noise fades, in the way your thoughts dissolve, one by one, like stars winking out at the edge of a dying galaxy, not in sorrow, but in completion, in the quiet satisfaction of a story fully told. Dark matter asks nothing of you. It does not need your belief, your understanding, your attention. It simply holds as it has always held, since the first moment of creation, and as it will continue to hold, long after the last star has gone dark, long after the last photon has faded, long after time itself has lost its meaning, and you, tonight, can do the same. You can simply hold to yourself, your awareness, your breath, without effort, without direction, without the need for anything to happen at all. You are not falling asleep. You are being received by the same stillness that holds the galaxies in place, the same darkness that cradles the cosmic web, the same silence that waits at the center of every atom, and at the center of every thought, and at the center of you. Let the last thought go now. It does not matter what it was. Let it drift away, like a galaxy beyond the cosmic horizon, still real, still present, but no longer yours to carry. The universe is breathing around you, slow and vast and old, and your breath is part of its breath. Your stillness is part of its stillness. Your darkness is part of its darkness. There is nothing left to solve, nothing left to find, nothing left to understand. The invisible universe has been carrying you all along, and it will carry you still, through the silence, through the dark, through the long, quiet, beautiful nothing that is sleep. And somewhere, in the furthest reaches of the void, where no light has traveled and no particle has stirred for 1 trillion years, the universe remembers that it once held a living mind, that once listened to its story and smiled and closed its eyes and rested. And that was enough. That was always enough. Rest now. The cosmos is holding you. The dark matter is holding you. And you are held